these warm-up questions, and please ask if you have some questions on it, and we'll work through some other all right, let's look at the other one that was the matrix, right? So you were supposed to solve so it's two equations, two variables, right? And so we were trying to solve it using matrices. And I know that matrices seem really kind of weird, and some people are like, why, do we have to do it this other way and stuff? And with the two equations, two variables, it's not as bad, but I realize, like, when you get to three equations and three variables, it is time consuming. But it is important for some of the fields that you're going into that you understand how you're getting this, how you're doing the process of this, and what all of these things mean. Because oftentimes, the reason why we like matrices is because when you get something really big, like 10 equations and 10 variables, that would be horrendous to try and do by hand. So we'd never have you do something like that by hand. But matrices are nice because you can actually have computers solve them. And so when you have so many equations and so many variables, then that's what, they're kind of used for a little bit more. But understanding how it works and why it works is what we're trying to get across in this. So let me set it up first of all. So we have, when we try and write this down, right, we're just using the coefficients. So on the top I have 3, -2, and then on the other side of that line is going to be a 10. So where this line is straight up and down, that's just where the equal sign is. All right, and again, make sure that you have things in the correct, that they're in standard form. We've got our x's, we've got our x column, we've got our y column, and we've got our whole number column. We want to make sure that each of those columns are lined up correctly. Okay, and then so on the bottom, our coefficients are 1, 1, and 5. All right, and I'll get to this a little bit more too about the different things that we can do with matrices. There's certain rules that we have to follow when we are dealing with matrices. But one thing that you need to remember is what you're trying to get this to look like. Your goal is that you want to get it so that there's ones along the diagonal, right? So you can kind of see here where there's ones along that diagonal and then zeros on that other diagonal on this 2 by 2. And it's important that, our upper left hand needs to be a 1 and our lower right hand needs to be a 1. Okay? And so this is our goal. This is what we're trying to get it to look like. And when we do that, the numbers that will end up here where I have these boxes will be what our x and our y are. Right? So we can solve this for x and y, which is what we're trying to do. It's just a different method to do this. So looking at this, the first thing that I would do, one of the things that we can do with matrices is we can switch any two rows. And so I'm going to start by switching those two rows because I see that I have a 1 on the bottom that I would like to have on the top, right? So if I switch these rows, now I have this 1 in the upper left-hand corner where I want it to be. And then my bottom row now will be 3, -2, and 10. All I did was switch the rows. Okay. All right, so then after I find this 1, then I'm going to move down and I'm going to make that into a 0 underneath it. So we're going to kind of have this little mapping that we're going to talk about. And, just if you follow the mappings that I'm showing you, then you'll be able to get to your answers a lot faster than if you just kind of haphazardly try and get, it into this 0, 1 or 1, 0, 0, 1 format. So I want to make this 3 in the bottom into a 0. And the way we can make zeros is if we think about if we were trying to eliminate the 3 or the x's here, we would be multiplying that bottom row, right, by a -3 and then adding those together. And that's exactly what we're going to be doing here with this. So this is what I'm going to say. So, I mean, we switched these around, but hopefully you can see that that's still what we're trying to do here. If I wanted to make that into a 0, that's how I do it. So I'm going to take and multiply my row 1 by a -3. So -3 times row 1. And then remember, after I multiplied it through, then I would add those together. So then I'm going to say plus row 2. So sometimes you'll see this little notation, and for some students it's kind of confusing to start off with to understand what it means. But that's all it's telling you is kind of like the steps that you need to do. I need to take -3 times it by my row 1. Then whatever I get for my answer there, I'll add it to my row 2. Now I'll do a little bit of work out here to the side so you can kind of see what I'm doing in my head. And, you know, because sometimes just writing it out is going to be a good way to start off with this. So -3 times row 1. So if I multiply that whole top by -3, I'd have -3, -3, and -15. All right, and that's all I did so far, was just this first part, that -3 times row 1. Now I want to add row 2 to it. So I'm going to put the row 2 underneath it. So 3, -2, and 10. And then I just need to add these guys together. All right, so notice when I add those together, I get a 0, which is what I wanted, and then -5 and -5. So when I write down my next matrix, notice what happens here. Okay, so I didn't do anything to the top row. Yes, I multiplied it by a -3 so that when I added them together, I would get that 0, but I don't want to keep that -3 multiplied through there because I multiplied everything by -3 so that I could easily just divide -3 out of everything again, which is essentially what we want to look at there. So my row 1 is staying the same. The only thing that is changing is this is going to become my new row 2. All right, so my row 1 will still stay 1, 1, and 5. And then on the bottom, 0, -5, and -5. Okay, let me stop right there a second because I just want to make sure, you know, that it's making sense what I'm doing here. And like I said, some of you, like this orange stuff that I did, you might be doing that in your head. And that's probably where you want to get to, but it's just really easy to make mistakes with negatives if you're doing that all in your head. So that's why I'm writing it out here. Okay. Questions, though, that I can answer to there? Where you see how I came up with that 0, -5, -5? All right, so after we found the 0 in the bottom left-hand corner, now we're going to, oops, it's just orange, we're going to go over and we're going to get this bottom right-hand corner made into a 1, right? So the easiest way to make 1s is by multiplying by the reciprocal of that number, right? So think about like 1/3, its reciprocal is 3/1. So if I multiply a number by its reciprocal, I always end up with 1. And so that's why when we're trying to make 1s in matrices, usually doing something like this where you're multiplying by the reciprocal, that's always a way that's going to get you there, okay? And so that means on this next matrix, I'm only doing something to the bottom row, to row 2. And I'm going to take that row 2 and multiply it by -1/5. Because that is the reciprocal, right? -5, the reciprocal of that is still is negative, but now it's 1/5. Right? And when I multiply those two things together, I get a 1, which is what I'm trying to do. Okay, so I'm going to multiply, so the top row is staying the same. Oops, didn't change the black there. Let's see here. Okay, so then the top row is staying the same. I'm not doing anything to it, but the bottom row well, 0 times anything is still 0. Negative 1/5 times negative 5 is 1. Negative 1/5 times negative 5 is 1. Okay, and so now I'm getting closer and closer to that goal. The only thing left now to do is I'm going to do this last one where I need to change that upper right-hand corner to be a 0. And again, to make zeros, you can multiply the equation by something and then add it to the other one, just like I was talking about here and how we would zero these x's out, right? Trying to like help you make connections between what you were doing when you were solving the equations and what you're doing when you're solving the matrix, so you can kind of see that. All right, so then on this one, right, I'm going to want to change row 1, so that's the row that I'm going to be adding to, right? But I'm going to multiply my row 2 by a -1. So I'm going to say -1 times row 2, right, because I want to make that into a -1, and then add it to that top row to make them 0 out. So added to row 1. Okay, is everybody, I can't tell how you guys are doing with this. Somebody, a few of you just like say something in the box. I really can't tell. Okay, let's keep going then, but please make sure you're speaking up if you are like, oh, I've got this question, I don't want to ask it because I'm probably the only one with that question. You're wrong, okay? You're going to have, there's going to be somebody else in the class that has that same question, so please, please, please speak up if you find that you're confused about something. All right, so again, I'll just do my little work over here to the side so you can see what I'm doing. So -1 times the row 2, so -1 times 0 is 0. -1 times 1 is -1. -1 times this other one is -1. And then I want to add it to row 1. So remember, when I'm adding it to, that's the row that's changing, right? My row 2 is exactly how I want it, right? 0, 1, and then I have my answer. So I don't want to mess with that. That's done. But I'm going to add it together now. So I'm going to add it to the 1, 1, and 5. Okay, and so then when I do that, when I add these together, right, I get 1, 0, and 4. And that's going to be my new top row, right, my new row 1. So 1, 0, 4 is in the answer part, and then my bottom row, my row 2 is staying the same, 0, 1, and 1.
Can we do that step one more time?
Yeah.
I'm confused.
Yeah. So I'm taking a -1 and I'm multiplying it by row 2. Right? So I'm taking this row 2 here. So if I do -1 times 0, that gives me 0.
0, okay.
And then -1 times 1 gives me a -1. And then again, I got to do the whole thing. So -1 times that other one is also a -1. And so that's just this first part, that -1 times row 2. And
okay,
then it
so
says,
then you just put it on the top there.
yeah, I just put it on the top
Okay.
because I'm trying to, add to it. Does it matter which way it's done here? No, I just need to remember that this that I'm finding is my new row 1.
Okay.
Okay, because that's what whatever I'm adding to is the one that changes. Notice that this, row 1 is what changed here. On this one up here where I was adding to row 2, it was row 2 that changed, right? So it's always the row that you're adding to, that's the one that's changing. The other one stays the same.
Okay, okay.
Okay. And then from here we can see, all right, well, this is my X column, And this is my y column. And so it's really saying like x plus 0y equals 4. Well, that just means there's no y there, so x equals 4. And then this is saying 0x plus 1y equals 1. So y equals 1. And so those would be my two solutions there. Okay. And I know it definitely takes some time to get used to. You know, it just seems kind of weird and, you know, and stuff. But let me show you, because some of you might still be confused on maybe some of the things that we can do with matrices. And so I want you to take a look at this. Let's see if I can make this any bigger. I don't know if that's helpful or not. But these are the different things that we can do. These are like our rules with matrices. We can switch any two rows, right? And then over here it just kind of shows where the top row is becoming the bottom row and the bottom row is becoming the top row. All right, we can multiply a row by a non-zero constant. We can't multiply by 0 because that will make the whole row 0, right? Because 0 times anything gives you 0. So you can multiply by any number except for 0. So that's what I'm saying, non-zero constant, right? So any number except for 0 you can multiply by. And so on the top row you can see that they're multiplied everything by 3, right? So, and usually we would just write those out. Like we wouldn't leave it as 3 times 2. We write that as 6. 3 times 5 is the 15. 3 times 3 is 9. All right, but they're just trying to show here, you know, what's happening, what we did there. Okay, another rule is that we can add one row to another row. Right? And so that's kind of what this one's showing, how you can add those rows together. And then another thing that you can do, and we do a lot of in this, is a combination of them. So like a combination of 2 and 3, where you multiply the row by something and then add it to the other row. Because think about what we did with those, you know, when we were solving the 2 equations and 2 variables. How did I make those variables eliminated? Well, I had to multiply one equation, right, by its opposite, so that when I added it together, it would zero out. So that's the same kind of thing that's happening here with this. Okay, so over here you can kind of see that I have written down the little mapping for 2 by 2 systems, right? But I'd like you to write this mapping down in your notes, because if you follow the arrows in the way that I'm telling you to do the mapping of this, it's going to take less time to get it done. And I say that because sometimes, and some of you maybe that have played around with these 3 by 3 matrices a little bit may have noticed that when you went and made something a 0 and then you did something else, and then that 0 was no longer a 0 anymore, it became something else. And then you're like, oh, right? Kind of like what Jordan was saying, or somebody was saying about a Rubik's Cube, right? Sometimes, you know, it feels like, okay, you know, like I get, you know, to one spot, and then like I mess it up because I, you know, did something else with it. And so if you follow this little mapping here, then you won't have that problem, okay? And so that's why I want to show this here. So please write this down in your notes. You'll be a lot less frustrated if you follow this. And a lot of times it's not shown in a lot of videos that you might find online, and I'm not sure why, but I just found that it helps a lot of students, so I wanted to do that.
Yeah, the videos wanted us to do it by the rows or by columns.
Yeah, and it can really mess you up. Did you find that to be true when you were trying to do it? Like you did one thing, yeah, and then you did something else and then it messed it up? Mm-hmm. Yeah. Yes. And so I'm like, why do they teach it that way when, you know, there's a perfectly good way to do this, you know, without, you know, messing things up that you've already changed, okay? And the other thing that I want to make sure that you write down, because remember, we're just trying to make zeros and ones. And so, you know, a way to make ones, you can always multiply the row by its reciprocal. All right, so if you have a 3 in a place that you want to make a 1, multiply that row by 1/3 and you'll get the 1 there. And so you can always get a 1 by multiplying by the reciprocal. Okay, and that's kind of another thing that's not really said very well, I think, on some of the videos and stuff. And then to make a 0, more often than not, this isn't an absolute, but more likely, I'd say 90% of the time, you'll either add one row to another row, or you have to multiply that row by a number and then add it to the other one to make the 0. And so if you can kind of keep these two things in mind, you know, and ask yourself, okay, I'm trying to make a 1. How do I make a 1? Okay, I'm going to multiply that row by its reciprocal. All right, now I need to make a 0 here. How do I make that 0? Oh, I need to multiply, you know, one of the rows by its opposite and then add it to it. Okay, so that's, I mean, so I really hope that you can see some benefit in these things as you're going through them going forward. And I hope that that will help you with that. Okay, trying to decide. How many of you, trying to decide, do you want me to work through right now? Should we do one matrix, like a 3x3 matrix, so you can kind of see how that works? Or would you rather go back and kind of talk about, you know, solving the 3x3s with the equations without the matrices?
I have some questions from 2.3, which is the 3x3s without the
Okay.
matrices.
So maybe let's do that first. And maybe what I'll do, let me come back over here. I think I'll put it underneath here, just so when I do stuff on that other page, we can see the matrix stuff a little bit more. All right, so I'm going to write down a 3x3 system, and let's try and work through this system. And I want your input, so I'm going to be asking questions, okay? And when I ask a question, either type it in or, you know, or unmute yourself. Please, you know, be responsive so that we can kind of, you know, I can see where you guys are at, if you're understanding it, if you're still kind of confused, if you're not sure, like if I ask a question and you're like, I'm not even sure, you know, just put in, I don't know, or something like that. So that helps me to know, you know, where you're at and stuff. Okay, so I can go back and get these things. So let's try this one, and I think this one will help you with some of the 3x3 equations that you're doing. Okay, so let's do, so we're going to solve the system. So write this one down, 2x minus 3y plus z equals 5. And notice how I put that little line through my z, because my 2's and my z's look awfully similar to each other. So you don't want to mix up, right, your 2's and your z's and stuff, so just be careful with that. X plus 3y plus 8z equals 22. And then the last one is 3x minus y plus 2z equals 12. And then I always, after I write down my equations, I go back and I double check that I wrote it down correctly, because too many times I've written down, like, you know, I've forgotten a negative somewhere, and then it just messes the whole thing up, and then you get really frustrated, okay? And so, like, go back, make sure you're always looking that everything is written down correctly. So I'm doing that right now, making sure I have everything written down the way it's supposed to be. Okay, and then we're going to start this out. So remember, we're going to pick 2 equations in which we're going to eliminate one of the variables. So first of all, which 2 equations do you think we should add together, and which variable would we be eliminating? Okay, so 1 and 2, and the y's, that looks really easy, right? It's already going to eliminate if we do that. So I totally agree with that. So I'm going to write these down again. So I'm going to do equation 1 and equation 2. So let me write these down. All right, and then I can see, all right, I don't even have to multiply that by anything because when I add these together, my y's eliminate. Okay, and so then I'm left with, when I add the other stuff together, 3x plus 9z equals 27. And so this new equation that I make when I add these together is going to be called equation 4, right? Because I already have 1, 2, and 3. So here's a new equation that I made. I'm going to call it equation 4 so it's easier to see which ones I'm talking about. Now I need to go back up to the originals and I need to choose 2 other equations, right? So which 2 equations do you think I should pick now? Okay, I like 2 and 3 also because one of them's a positive and one of them's a negative. And so whenever if I can, have that already done, that makes it so much easier for me. Because sometimes when you distribute a negative through, there's just more chance for errors on that. All right, so really what I'm going to do is I want to multiply my equation 3 by 3 so that when I add it to equation 2, those eliminate out. All right, so let me take that equation 3, right, and I'm going to show here that I'm going to multiply through by 3. So 3x minus y plus 2z equals 12. And then my equation 2 was the other one I wanted to add to it. Oops. So, and that's the x plus 3y plus 8z equals 22. And then I still haven't distributed that 3 through yet, right? But some of you already do that on that when you write it down. That's just fine with me. All right, but I'm going to write it down underneath here. So that will give me 9x minus 3y plus 6x, or 6z, and then equals 36. Okay, and again, remember, I have to eliminate the same variable that I did when I made equation 4. So since I eliminated y's to get equation 4, I also need to eliminate y's again. Right, so the y's are gone, and I'm left with 10x plus 14z equals 58. Right, and now I've made equation 5. Okay, so notice, right, I have equation 4 and I have equation 5, and I want you to notice the variables, right, x and z and x and z. And so then it just becomes one of those, 2x2s that we were working with, the very beginning, like in 2.1, where you were doing these. So now I'm going to put these together, right? And then I've got to figure out how I can eliminate one of those variables. So let me write equation 5 underneath here. I'll call it equation 5 here so we remember. So now, what do I want to do to try and eliminate a variable? Can somebody just unmute yourself and tell me? It might be easier than writing it in the chat.
You need to multiply by, if you wanted to do the x's, you could multiply the top by 10 and the bottom by -3.
Okay, perfect. Does everybody see why he's saying that? Right, so because this is going to give me 30x, and then on the bottom I'd get a -30x, so that when I add them together, those zero out, right, is what we're trying to do. Okay, so let me rewrite those down distributed through. So I'd really have 30x plus 90z equals 270. And then I get negative 30x. All right, let's see, what is negative 3 times 14? Is that negative 42z? And then what's negative 3 times 58? I have that one. So I go to 174. Double check my stuff here. Okay, so then my x's are gone, and I'm left with, so 90 minus the 42, right, is going to give me positive 48z, and then negative 270 minus 174 is going to give me 96. And then I'd need to divide both sides by 48, and so that means z would equal 2. Okay, so I've got part of my answer, right? Remember, I'm writing my ordered triple, my x, my y, and my z, and I found z is 2. All right, so I've got part of it. Now I need to go and find the other one. What could I do from here? So now that I've found z, can somebody tell me what can we do with that 2 to help us find another variable?
You can put z back into either, like the number 2, back into either 4 or 5 for z.
Exactly. So take z and put it into 4 or 5. And, I mean, 4, right, looks a little bit easier for me because the numbers are just smaller, but it wouldn't matter which one you put it into. Okay, so I'll write it over here. So let me write down so you know which one I'm doing. So I'm taking equation 4, right, and I'm going to put this z equals 2 into that. So that's going to give me 3x plus 9 times 2 equals 27. So 3x plus 18 equals 27. Now I need to subtract my 18 over. So 3x equals 9, and then I'll need to divide by 3. So x equals 3 on that. Right? And so that's going to be part of my ordered triples. Now there's just one thing left to find, and that's y. So if I know what x and z are, how can I find y?
Put the 3 and the 2 back into one of the first equations?
Yeah, so go back to 1, 2, and 3. I'm just going to choose 1, but like I said, you can choose any of them, and you'll still get the same answer. All right, so on 1, I'm going to have 2 times x, which is 3, and then minus 3y, we don't know what y is, that's what we're solving for, plus z, which is 2, and then equals 5. Well, here I get 6 minus 3y plus 2 equals 5. Let's combine those like terms together. So negative 3y plus 8 equals 5. Subtract my 8 over. So negative 3y equals negative 3. Let's divide by negative 3, and y equals 1. So now I found my ordered triple there is 3, 1, 2. And that would be my answer. Okay. So yeah, so if you're kind of breaking it down to how you do this, right, you start with the 3 equations, and you decide which variable am I going to eliminate. We decided to eliminate y's. So I added 1 and 2 together, and the y's already eliminated. And when I added the rest of it together, that made my new equation 4. Then I go back up to the original 3 and choose 2 other equations and make sure that I eliminate the y's again, right? Whatever I eliminated the first go around, I've got to eliminate here. So I eliminated my y's again, and when I added the rest of the equations together, I got my equation 5. Now I put my equation 4 and 5 together and do the process again. Now eliminate one of those variables, right? And then that gets us to our first variable, right, part of our answer. And then from there, you're really just doing back substitution, right? So you'll take your answer, put it into either equation 4 or equation 5. You get an answer there, and then you take both of those answers and put it back into either 1, 2, or 3 to find your last variable.
One of the problems on the homework that I was having a hard time with was 2 of the things had 3 variables and one of them only had 2 variables.
Okay, and actually that makes it a little bit easier. So if it, you know, do you have it written down?
I just wrote down that it was number 7, I think. But I can pull it up on my phone.
Okay, yeah, because if you can pull that up, that might be...
Yeah. Let me pull it up and I'll read it to you. Give me just
Okay.
1 second. I'm getting it right now.
Because really, in that case, it actually makes it a little bit easier, even though some people look at it and go, oh, that looks so weird. But you already have one of your equations made, like one of your equations is already your 4 or your 5th equation. So I'll show you what I mean by that.
Is that on the 2.3?
Yeah, is that 2.3?
Yes, it was 2.3.
But is that what you guys came up with? Okay, and remember also that tonight I have office hours from 7 to 8 p.m. So, you know, if we don't get through everything today that you wanted to talk about, you know, in class and stuff, please come tonight to my office hours. Remember, that's on my WebEx, my virtual office, and the link to that's just on the home page. So you can, you know, come to that and stuff. Okay. All right. I think I'm going to move on and kind of show you now how to do that one with the parameters, and then we'll move into talking about the matrices and stuff like that. Might not take a break today just because I know we have a lot to cover today, and we might go a little past 4 o'clock even as it is to try and get through what I want to get through today.
So is the quiz due tomorrow?
Yes, it's due tomorrow. So,
Okay.
like I said, if you can come tonight to go to, you know, to come to my office hours and stuff like that, that would be really helpful. And also remember, there's a workshop tomorrow night that you could go to also. So keep those things in mind, because I know this kind of takes practice, and you know, but let's do one where there's those parameters that you have to do. So let me write one of those down. So let's see, we have negative 3x plus 5y plus 2z equals negative 19. 5x minus y plus 4z equals negative 5. And then 4x minus 2y plus 2z equals 2. Okay. So on this one, you know, I mean, your directions could say, you know, to write your answer, you know, like parameters of z, it could say x, it could say y. So you've got to watch what it's asking you, how it wants you to write your answers. And I'll go over that a little bit more of what that means when we get down to, you know, solving this and stuff. So, but it doesn't always have to be like, you know, parameters in terms of z. It could be in terms of x or y. So on this one, right, if I look at this and I'm trying to solve this, it looks like to me that I might want to get rid of the z's first. Those look probably the easiest to get rid of, but we could get rid of the y's also. Those look not too bad either. So you just have to decide what you want to do on these, you know, how you want to do this. But let's take equation 1 and equation 2, and I'm going to multiply my equation 1 by a negative 2, so that when I add it to the 4z, those are going to eliminate. Right, so again, just to save a little bit of time here, I'll just write it out here so you can kind of see what I'm doing. So I'm going to take and multiply this equation by -2. So when I write that down, I get positive 6x minus 10y minus 4z equals positive 38. All right, make sure I'm distributing that -2 through to everybody there, okay, and watch your negatives closely there. All right, and then my equation 2 that I'm adding to it, so I've got 5x minus y plus 4z equals -5. So when I add these together, see my z's eliminated, and I'm left with 11x minus 11y equals 33. And now that's my new equation that I'm going to call equation 4. Okay, and then I'm going to go back up to my original 3 and try and pick another pair that I can try and eliminate. So maybe this time I'm going to do equation 1 with equation 3. And with equation 1 this time, I'm going to multiply my equation 1 by a -1. Right? So when I write that down, my equation 1, whoops, try and keep consistent on my colors here so it's easier to read along here. So when I distribute that -1 through now, I get a 3x minus 5y minus 2z equals a positive 19. And then I'm going to add that to equation 3, okay, which is 4x times 4x minus 2y plus 2z equals 2. Okay, so I add these together, I see my z's eliminate, right? That's what I eliminated the first time, so that's what I need to eliminate the second time. Right? And so when I add these together, I get 7x minus 7y equals 21. Okay, and now that's my equation 5. All right, so now I'm going to put my equation 5 and equation 4 together and eliminate another, eliminate another variable. It's all right there. Okay, and so now I'm going to multiply my top equation by -7 and my bottom equation by 11, right? Notice how I'm just multiplying it by, like 11 was on the top here, so I'm multiplying that by the bottom one. 7 was on the bottom, so I'm multiplying by the -7 on the top because, again, I need these to eliminate out. So when I do that, let me multiply across the top. So my new equation 4, right, is going to say -77x plus 77y equals, let's see, -7 times 33, 231, and then let's distribute the 11 through now, so positive 77x minus 77y, and then 11 times 21 is 231. So I get to this point where I see everything, right? My x's are gone, my y's are gone. So that means on this side of the equal sign, I just have 0, right? Everything is gone. There's no variables left to solve for. And then on the other side, I also get a 0. So 0 equals 0 is a true statement. And whenever I come up with, an answer like that where it says 0 equals 0, that does mean that it's going to be infinite solutions. Okay? But it asks you to write these with parameters. And since I eliminated z here, it would be harder to write the parameter with z, so I'm going to actually write it in terms of y, but you can write it in any way. You know, if so, maybe starting off, you'd want to look and see what it's telling you, how to write the parameters. If it says to write it, the parameters using z, then you don't want to eliminate z first, okay? Because really what you're going to do here now is you're going to take either your equation 4 or equation 5. So that's what I'm going to take here. I'll just kind of do the rest of this over here so you can see what I mean. So I'm going to take this, and so I'm going to So basically what this means is we want everything in terms of that number. So I'm going to solve this equation for x, and when I do that, I'm going to be left with y in my answer. Okay, so when I'm writing down my ordered triple here, okay, and I decide, so let me solve this one here. And so if I solve this for x, I'm going to add my 7y over, and that will give me 7x equals 7y plus 21. And then I'm going to divide everything by 7. So I get x equals y plus 3. All right, so these are going to be in terms of y. So y is just going to be y. But x, to find my x value, I would take whatever I used for my y and add 3 more to it. Okay, so this is like trying to help us figure out, because remember, this is like infinite solutions. There's so many different answers that we can come up with. So we need to list out like how we can find all of the ordered triples that are going to work for it. It doesn't mean that anything will work, but it just means whatever I choose for y, I'll add 3 to that, and that will give me, that will give me what my x is. Now I need to find my z, right? Well, to find my z, let me see if I can kind of show what I did here. Now to find my z, I need to go back up to one of my original 3, and maybe I'll just use equation 3 here. Right? I'm just looking for ones that have small numbers in them because I like that more. So I've got my 4x minus 2y plus 2z equals 2. And I know that y plus 3 is what my x is. So rather than putting a number in place of x now, we've got to put this expression in place of x, because x can be a whole bunch of different things. And so I can't say that x is just 3 or x is just -5. It can be a lot of different things. So I'm going to substitute that y plus 3 in place of x here. Okay, so I'll have 4 times, in place of x, I'm going to put my y plus 3, and then minus 2y plus 2z equals 2. And remember here, I'm trying to solve for z. All right, that's the last one that I have here to solve for. I know my x, I know my y, now I need to find z. And these 2's are kind of looking like z's, so be careful with that. All right, so let me distribute this guy through. So we get 4y plus 12 minus 2y plus 2z equals 2. Let's combine some like terms together here. So I've got 2y plus 12 plus 2z equals 2. All right, remember I'm trying to solve for z. So now let me subtract my 2y over and my 12 over to the other side of the equation so I can get z by itself. Let me scroll down just a little bit here. So that's going to give me 2z on this side equals negative 10 minus 2y. And now I just need to divide everything by 2. So z equals negative 5 minus y. And so now that's what I know z is, so that's going to go here. Right, so I've got negative 5, and you could write it as negative y minus 5 or negative 5 minus y. It doesn't matter. Either way is perfectly fine, right? But then, so if we were trying to find any kind of an ordered pair, right, on this, like we can see, or ordered triple, we can see there's a lot of different things that could come up. So if I say that y is 0, well, then 0 plus 3 is 3, and then negative 5 minus 0 is negative 5. So here's one possibility for an answer, but that's not the only answer, right? What if I said y was 1? Right? Then I'd put y, 1 in place of y here. Y plus 3 is 4. And then negative 5 minus 1 would give me a negative 6. So here's another one, right? So, and there's going to be an infinite amount of these, depending on what you choose for y is going to change, right? What your x and your z are. But they're always, you know, there's like a system to them. There's a certain way these guys are related to each other, is what we mean by finding, you know, this, you know, solving it in terms of another variable. Okay, so what questions can I answer there? I know that's like, some people go, oh my gosh, that is just crazy, but other people are like, no, I get it.
That helps me a lot on figuring out how to do that one now. Thank you.
Yeah, does everybody understand too that you got to watch and see what it says it wants the parameters in? So if it said it wanted a parameter, you know, write your answer in parameter of z, then I wouldn't want to start eliminating my z's. I'd want to like eliminate my y's or something instead, because it's just going to make it harder to do that. Okay, so I mean, this is a perfectly good answer, and it's the correct answer if the parameters are y, but you'd have a kind of a different look of it if it said write it with the parameters of z. So that's why they have to say which parameter they want on that. Okay.
So whichever one that they ask for, that's always going to equal itself.
Yes, exactly. So whatever, if it said write it with parameter of z, let me scroll down here. Right. So if it said, you know, parameter of z, then when you write your ordered triple, z is going to be your z. And then you'll go and find out what your x and your y are. That's a good question, right? Or if it said find it with parameter of x, right? Then don't eliminate your x, but your x is going to equal x, and then all of these are going to be in terms of x. So it'll say like x plus 2 or negative x plus 3 or something like that, right? They'll all have x's in them. Does that make more sense? I know those are kind of weird. Let's see, somebody said I put z in on that problem with infinite solutions and I still got 0.33 points right. So can you tell which part you missed, Jordan? It sounds like you put z in, but for some reason it's saying that you missed the other two. So double check that when you're solving, like when you go back up and, you know, take either your equation 4 or your equation 5 and you solve, you know, for that is what you have there. Oh, okay, sorry. Sometimes I don't see the chat, so until later, so. Okay. Woo! Woo-wee, right? You guys doing okay? I know there's a lot to this, and I know, you know, like I don't want you to get overwhelmed and stuff like that, and any way that you can try and just be like, okay, how can I make this into a game? How can I make this like, you know, like a Rubik's Cube or something like that, or a puzzle. Well, I've got to do this, and then I do this, and then I do this, and then I do this. And sometimes that's, you know, kind of remembering the algorithm for this is going to be an important part of being able to solve these. So, all right, well, let's go and look at some stuff with matrices now, because I know that some of you really wanted to look at the matrices, and like I said, we'll get as far as we can, and then if you have more questions, please come tonight, you know, for the office hours and stuff, because I am more than happy to help you then. And if you can't come to office hours, just set up a time, you know, with me. Probably have some time tomorrow that I could help too. So if you're, you know, like, I can't come tonight, but I need more help, then just let me know and we can make a time tomorrow. Okay. All right. So how, on a scale of 1 to 10, 1 being, so this is, I'm talking about just the 2x2 systems right now, right? So on a scale from 1 to 10, how do you feel about being able to solve the 2x2 system? So 1 is, I'm really confused. 10 is, I think I have a pretty good grasp on how to solve those 2x2 systems. So write something into the chat so we can see where you guys are at. There, on the 2x2s. Okay, let's do another 2x2 then. So it looks like we're kind of all over the place. A few of you are like, yeah, I got it. But most of you are like, I still could use a little bit more help on that. So let's start with one of those. Okay, and, you know, and I know most of you are still really, you know, confused with the 3x3, so we'll definitely get to those. So don't worry about that. Okay, but let's look at this one. So let's try and solve this system using matrices. And I'll kind of explain through what I'm doing as I go along here. And make sure that if I say something, you know, that you're like, oh, okay, that makes more sense now, write that down in your notes. Something that I said that kind of made it click for you, so that when you go back and do your homework, you know, or try and finish this up, you're like, oh yeah, Becky said this, and you know, and so just make sure your notes are being useful to you, I guess is all I'm trying to say. Just writing the examples down exactly how I have them isn't always going to be what you need, right? All right, so if I write it out in matrix form, remember all we're doing is getting rid of the variables, but writing it down the same way, right? So I've got 5, 3, and then 5 along the top. On the bottom, I've got 1, 2, and 1. Okay, so again, remember, we're trying to use this little, you know, this little mapping here. So that means I want to get a 1 in the upper left-hand corner first. That's what I want to do. So who has an idea of what we should do to get a 1 in that upper left-hand corner?
Should we move row 2 up to row 1?
Yeah, let's just switch them, right? So that's nice, because if we just switch these two, then we already get that 1 in the place that we want it. Okay, so I'm just going to do that right here. So I've got 1, 2, 1, and then 5, 3, 5. Okay, so after I get 1 there, then remember, I'm going to go need to get that 0 in the bottom left. So who has an idea of how we could make 5 into a 0?
Multiply the top row by -5.
Yeah, so now that I have a 1 here, I'm going to use that to help me. All right, so that means I can use this by multiplying by the opposite of that 5. So I'm going to take -5 times that by row 1 and then add it to row 2. And remember, whatever one I'm adding to is the one that's changing. So sometimes students just find it easiest to, you know, before they do any of the work here, they're like, okay, Row 2 is the one that's changing, so I'm going to go ahead and just write row 1 in so I don't forget that that one's not changing. Okay, and then if you need to do, little work over to the side, like I did before, you can do that. So negative 5 multiplied by all of row 1, that would say negative 5, and then negative 5 times 2 is negative 10, negative 5 times 1 is negative 5, and I'm adding that to row 2. So I'll just put row 2 underneath that. So 5, 3, and 5. And then when I add those together, right, I get 0, negative 7, and 0. And remember, this becomes my new row 2, right? So make sure you're writing down in such a way so you remember. Okay, so that's going to come here now. So 0, negative 7, and 0. Okay, so I have my 1 and I have my 0. So now when I go up over here, right, next one that I need to find is my 1 in my lower right hand corner. So let's do that now. So to get a 1, how do I make a 1 here? How do I make a 1?
Multiply by the reciprocal?
Yeah, so what is the reciprocal that I want to multiply by? The reciprocal of what? Because sometimes that's confusing to some people. What does she mean by the reciprocal? Which reciprocal am I doing?
So it would be the reciprocal of negative 7, so it would be 7 over 1.
So it's already negative.
1 over 7.
Yeah,
1 over 7.
and it needs to be negative still, right? So negative 1/7, because a negative times a negative is going to give me a positive. And I'm multiplying that negative 1/7 by all of row 2. Right, and again, if I do just like a little workout to the side here or something, right, if I'm saying negative 1/7 times negative 7 over 1, right, negative 1 times negative 7 is 7, 7 times 1 is 7, and that just reduces to be 1, right, and so that's what I'm trying to do. So that's why I've got to make sure both of those are negative there, or that they're both positive. All right, so then my next one, right, only row 2 was what was changing. So let's leave row 1 just how it was. And when I negative 1/7 times 0 is 0. Negative 1/7 times negative 7 is 1. Negative 1/7 times 0 is 0. Okay, so I know what y is now. Y equals 0. Okay, and so my last thing that I need to do, right, is make it so that my upper right hand corner is now a 0. So how can I make that 2 into a 0? You can tell me how I would do that.
Multiply the bottom row by negative 2.
Okay, so negative 2, oops, I have to use red, negative 2 times row 2, and then add it to row 1. Right, because think about what I'm saying here. If I make this into a negative 2, that negative 1, sorry, sometimes I can't see what I'm saying. If I make this 1 into a negative 2, and then I add it to that 2, that's going to give me 0. Right, so on this one, I'm adding to row 1, so that means the row 1 is the one that's changing this time. So I'm going to leave my row 2 alone. All right, so I still have 0, 1, and 0 on the bottom. Right, and then if I multiply the top, and I'll kind of show you the way maybe I do this in my head, and you can decide whether you want to show your work like I'm showing in orange over to the side, or just doing it in your head. But usually I'm saying, okay, negative 2 times 0 is 0, plus 1 is 1. All right, so you could just kind of do that in your head there, but sometimes that gets confusing for some people. Negative 2, right, so I'm doing negative 2, trying to use my cursor, negative 2 times 1 is negative 2, plus 2 is 0. So I'll put a 0 there. And then the last one, negative 2 times 0 is 0, plus 1 is 1. Right? Did that make sense what I did there? Like I said, you can do your work over to the side like I did like this if that's more helpful for you. But then I can see I've got my two answers now. I've got x equals 1 and y equals 0. And those would be my answers. Or sometimes they'll say to write it as an ordered pair. Right? But either way. Okay, questions on that one? It really is just going to take some time to play around with it and stuff like that to really be able to get these down. All right, I want to try and get through a 3x3 also before we go today. So let's do that next. And then if some of you want to stay on a little bit after, you're welcome to stay on, and I'll just give you a couple of practice ones that you can kind of practice with so we can see, do you have it down, or, where are you getting stuck? Because sometimes that's kind of figuring out where are you getting stuck. Okay, so again, we're going to solve using matrices. Right, and these are my equations. So x plus 2y minus 3z equals 9. 2x minus y plus 2z equals negative 8. And 3x minus y minus 4z equals 3. And again, I'm going to double check that I wrote down everything correctly. So I don't want to miss a negative or something and have that mess me up the whole time. Okay, so I want you first of all to write that in an augmented matrix, right? So write it in matrix form. Let me give you a chance to do that. Okay, so matrix form on this would be 1, 2, negative 3, and then 9 on the other side. 2, negative 1, 2, and negative 8. 3, negative 1, negative 4, and 3. All right. So I wrote the little mapping thing over here to the side, okay? And just a warning, and in this one, we are going to get some fractions as we're going through it to solve it. And so have your calculator handy. And some of you were asking before about, a calculator that's good with fractions. Oftentimes you'll really want that for these matrices. It will make your life a lot easier if you're not having to go and find common denominators and doing all of that work out to the side and stuff like that. And like I said, you can get them for probably under $15, between $15 and $20, just depending on where you go and stuff, that work with the fractions and make it super easy for you, okay, with the fractions. So remember, I'm going to find the 1 in the upper left-hand corner, and then I'm going to go down and find that 0 underneath it, then go to the right and find that 1 that's in the middle, and then go back and find the lower left-hand 0, right? And then pretty much I just go to the right and then go up and over. But this first part is really important that you do it that way. It'll make your life a lot easier, okay? All right, so Amber said she found a TI 30XS for $20, okay? So awesome. And that one's a really good one with fractions, okay? And you'll see on this what I mean. Have have your calculator handy so that when we're working through this, with the fractions in it, right, you can kind of follow along with me as we're doing it and not get so bogged down by those fractions. All right, so I already have a 1 in that upper left-hand corner, so that's good. So the next thing I want to do is change that 2 into a 0. And remember, the way I can make zeros is by multiplying, right, that 1 that I have above it by its opposite and then adding it to it. Okay, so that means I'm going to take, I want to take -2, oops, let me write it in a different color, -2, and I'm going to multiply that by row 1, right, so I have a -2 there, and then I'm going to add it to that 2 to make a 0 there, so add it to row 2. Right, so this is just a little shorthand notation of what I'm doing there. Right, whether you choose to write that out there or not, I would encourage you to write it somehow there or to be doing your work out to the side, because it will just really make it a lot easier to follow what you did, and maybe if you're trying to figure out where you made a mistake, what you did there. Okay, so I'm going to write the work out to the side here because I just find for a lot of students it's helpful. So -2 times my top equation is going to give me -2, -4, +6, and then -18. Okay, and then I'm going to add that to row 2. So 2, -1, 2, and -8. And so then when I add these together, I get 0, -5, 8, and -26. And so remember, this is becoming my new row 2. Right? So if it helps you to write a little like R2 out to the side there so you remember, then do that. And that's the only one that was changing. My row 1 stays the same, and my row 3 stayed the same. Right? But my row 2 is now 0, -5, 8, -26. Okay? All right. And you can actually do, I guess, this. You could go and find, with this mapping, you could do like the 1, 0, 0, and then go back up and get this 1 and come down here. It would also work that way too. But let's just follow this along the way I have here. So now I want to get a 1 in the very center where that -5 is. So remember, to make 1s, we can multiply by the reciprocal, right? So this is where I'm going to get some fractions in it. But that's okay. Like, don't let those fractions scare you, right? Get a good calculator that will help you with it. You'll be just fine. Okay, so I'm going to take my row 2, and I'm going to multiply by the reciprocal of -5, so that would be -1/5, times by my row 2, so that I can get a 1 there in the very center. That's the next thing I'm trying to do, right? And so when I do that, right, again, my row 1 and my row 3 didn't change. Okay, and sometimes people will do more than one thing in one matrix, but other times students get kind of confused by that. Trying to take care of more than one thing in there. So I'll just do it this way. So if we take -1/5 and times it through here, we got 0. -1/5 times -5 is 1. -1/5 times 8 is -8/5. Right? Just multiply across the top, multiply across the bottom, and then -1/5 times 26. -26 is going to be +26/5. Okay, so I get these fractions, but again, try not to freak out, okay, because you can do this. Okay, all right, so now we need to go and make that 3 into a 0. All right, so let's look at that 3 and get that made to a 0. Okay, does anybody want to tell me how could we make that 3 into a 0? Let me hear from somebody. Nobody knows.
Multiply the top by -3 and then add the 2, maybe?
Yeah, that's exactly right. Okay, when we're making zeros, right, multiply the one row by its opposite and add it to it, right? And we always want to use these ones that we have to our advantage. Okay, so that means we're going to have -3 times row 1 and then plus row 3. Right, so row 3 is the one that's changing this time. But let's go ahead and write down row 1 and row 2 so we don't forget. We don't need to change anything with those guys. Right, and so when I do this part, right, -3 times row 1, well, that will give me -3, -6, +9, and -27. Right? And then I'm adding it to row 3, so put row 3 underneath it, so 3, -1, -4, and 3. And then when I add those together, I get 0, -7, 5, and -24. And that, remember, is becoming my new row 3. Right, so that's coming down here. So that's going to be 0, -7, 5, and -24. Okay, is everybody okay there with me? Questions up to this point, please speak up. You're not going to be alone if you have a question, I promise. Okay, so now we need to get that -7 to be a 0. Okay, I know some of you are like just trying to copy it all down. Let me try and pause a little bit. Sometimes when I get like really excited and start explaining things, then I, maybe start talking a little bit too fast and stuff. So please, I would not feel offended if you say, Becky, can you slow down a little? Okay, because I want to make sure that the understanding is there as well as having the time to copy it down. Okay, so now to make a 0 where the -7 is, again, I need to do that thing where I multiply this 1, right, that's above it, by its opposite. So I'm going to multiply row 2 by 7 so that when I add it to -7, I get a 0 there. Right? That's always a way I can make a 0. Multiply the row by something, add it to the other one. So that means I'm going to do 7 times row 2, right, all of row 2, plus row 3. Okay, so which row is changing this time? The third.
Row 3.
Yep, row 3. Oops, put down blank. Okay, so I'm going to write down equation 1 and equation 2, just like they are. And then when I'm trying to find my row 3, maybe just, I'm not going to say it out loud, I'll do the work over here, but I want you to try and figure out what this new row is going to be. Okay, so I won't say anything out loud, you can just look over here when you're done with yours. My calculator. Okay, and if some of you are kind of new to your calculator and aren't quite sure, like, because if you tried to put this into your calculator, it might change it to a decimal. But on most of the calculators, just to make sure there's like a little button. Oftentimes it's just above the enter sign, but sometimes it can be in a different place. But you'll see something that kind of looks like two arrows pointing away from each other, right? And that changes from a fraction to a decimal or a decimal to a fraction, okay? Other calculators, there's just like an F to a D button or something like that, okay? Sometimes it has it like that, because you can go either direction, fraction to decimal or decimal to fraction, okay? But make sure that you can see like how to come up with these, right? Because otherwise you're going to have to get a common denominator there, like make that 5 into 25 over 5 so that we have a common denominator of 5 and then combine those together. So it just makes it go a lot quicker if you have a calculator that will work with the fractions, okay? You wish you would have known what, Angeline?
I didn't know that my calculators had that this whole time, and I've been doing all this extra work.
Oh, well, I'm glad that I brought that up then so that you could see that, because from here on out, you're like, okay, I don't have to do that, right? So look for those buttons, and they're such a lifesaver, okay? So it makes it just a lot less time consuming. All right, and then we want to change that negative 31/5 into a 1. So again, we're going to multiply by the reciprocal on this. So that's going to be our next step. So I'm going to take and multiply row 3 by the reciprocal, which is negative 5 over 31. Okay, and I know that looks kind of ugly and stuff, but I mean, it's not going to be too bad, even if you wrote these out, to the side. So negative 5 over 31 and negative 31 over 5, right? These just cancel out and you're just left with 1, which is what we wanted to end up with there. So let me kind of do this. And then I get 0, 0, 1, and now I need to take my 62 over 5, and like I said, so your calculators, a lot of them will do this, times it by that negative 5 over 31. Well, those 5's divide out, and 31 goes into 62 twice. So we've got negative 2 that's left there. All right, so that, even though there was like fractions and stuff, we ended up with this nice whole number there, right? This negative 2 instead. Okay, and so there's two different ways to solve it, and I really don't care. I mean, what I usually do is get it to this point where I have the zeros along the diagonal, right, along here, and then you can see that that once they're along that diagonal and there's the zeros, kind of in that triangle underneath it, if you have it to this point, then this is called row echelon form. So there's reduced row echelon form, where you go back up and you can continue doing the matrices to get this to be a 0, 0, and 0, right? Get those zeros in the upper right hand side of it. But most people are kind of opt to be like, okay, I'd rather not keep going with those with these matrices, so I'm going to kind of convert these back now to equation form. Okay, so let me show you what I mean by that. So this top equation, if this top row would convert to be 1x, so just x, plus 2y, minus 3z equals 9. Right, I'm just changing it back to equation form. And then the next row, right, I don't have an x anymore, so I have 1y minus 8/5 z equals 26/5. And then I have z equals negative 2. right? And so now I can just do back substitution from here. So I know that z equals 2, so I'm going to put that negative 2, not 2, in place of my z in that equation right above it so that I can solve for y. Okay, so let me do that over here. Come over here to kind of do it. So I'll have y minus 8/5 times negative 2 over 1, right, because I'm timesing it by negative 2, equals 26/5. So that'll give me y minus, well, I guess I got a negative times a negative, so that's really going to be plus 16/5 equals 26/5. And then when I subtract that 16/5 over, all right, I've got a common denominator and everything, so I'm good there. Y equals, oops, that should be negative, 10/5, which is 2. So y equals 2, right? So I found my z, right, my ordered triple up here. So I got my z is negative 2, my y is 2, and then my x I need to find by going back up to that top equation. So I get x plus 2 times the 2 that I found there, y is 2, so put 2 in place there, minus 3 times my z, which is negative 2, equals 9. I'll just simplify this. I'll subtract the 10 over, and I get x equals negative 1. So that would be my answer there, negative 1, 2, and negative 2.